Now let us see a few more 3D graphic terms. So we start with modeling. Modeling is the construction of geometric objects in 3D scenes. So models actually describe the form of objects, but not their material properties or how they move. Model only describe the forms of the object. So construction of these geometric objects in this 3D scene is actually our modeling. The node. What happens in computer science? A node is an abstract container of information. Means they are generally attributes that store data, but in terms of 3D graphic program, these nodes are connected together to form a network called a screen graph. Means if you understand that see these are 2 points and we connect it, this may be a node or in the form of a tree. This may be a node, this may be a node. So these are the nodes. These nodes are connected together to form a network called a screen graph. For example, in Maya, a very famous software, a primitive object such as sphere is made of 3 nodes, each storing a different type of data: a primitive node, a shape node, and a transform node. Then NURBS. NURBS are non-uniform rational basis spline. NURBS are non-uniform rational basis spline. This is a particular type of spline curve with weighted central points, right? Which are actually weighted control points. It's a type of spline curve only. In orthographic projection, this is how we convert our 3D object to 2D object. So a flat 2D view of a 3D object or scene. So technical drawings, blueprints and floor plans, they are all an example of orthographic projections. And in 3D projection, these orthographic views such as front, top and side are very common. And these orthographic views are always aligned with the axis of world Cartesian coordinate systems. So they are necessary because 3D perspective views always introduce visual distortion of object size, placement and distance. 3D perspective view is what you see by your eyes, the way you see. But while you are making it or modeling it, you have to have a size, proper size. For that, orthographic projection is the best. So the ortho view is unlike a perspective view because an ortho view shows no indication of depth or distance, right? This is the importance of orthographic view. While in this perspective view, an object is displayed smaller as it's move away from the viewer. Like if you watch from a distance this railway track, at certain points far away from you, these 2 lines tend to or seem to be converging together. This is your perspective view. So parallel lines appear to converge at a vanishing point in your perspective view. So simulated rays of lights from the 3D scene called lines of projection all converge at virtual lens camera lens. So in an ortho view, the size of the object in the view does not depend on its distance. It will be same. So 2 objects of the same size are drawn, the same size on the screen, no matter how far away they are. So parallel line remains parallel and they never converge. The lines of projections are at right angles to the screen. Then coming to particle system. The right of this type of procedural animation that reproduces the appearance of fuzzy phenomena such as clouds or fire, right? So particle system may also be applied to animate many objects in scene such as flock of birds, etc. Then coming to patch, a deformable parametric surface used for creating curved objects. It can be based on a Bezier or a NURBS mathematics. So the curvature is controlled by the position of the control vertices. Then perspective. This is the representation of a scene in which Parallel lines are depicted as converging, as we have earlier discussed, in order to give the illusion of depth and distance. This is how we see from our eyes. Like an orthographic view, a perspective view is a projection of this 3D onto a 2D screen. However, in this perspective view, the line of projection converge in a like this. They converge in the virtual camera, which is this simulated point of view. So, coming to this pivot point, the center of an object transforms in the center of its local coordinate system. The center of the object transforms to the center of its local coordinate system. So, object moves, rotates, scales relative to the location and the orientation of this pivot point, also known as the anchor point in some computer applications. Pixel, abbreviation of picture element, the smallest possible element of a picture. So a digital image is defined by a discrete number of pixels which is arranged in a 2D grid or a mosaic in rows and columns. And many these pixels blend together in the human eye and brain to give the illusion of this continuous unbroken image. The pixel ratio, the proportion of pixel width to the pixel height. So in most cases pixels are square, giving a pixel ratio of 1:1. However, in some formats they use non-square pixels such as DVDs, which have a pixel ratio of 0.9 to 9. So this can cause headaches when working with non-square pixels formats or hardware that only display square pixels. So all desktop computers use square pixels to display their graphic user interface. Polygon. This is a closed 2D plane figure bounded by straight line or edges, like this. So this is a polygon. Polygons can be connected to one another in a 3D space to create mesh objects, and in some computer graphics applications, these faces and polygons are synonyms. But sometimes in this term face, they refer specifically to a triangle only. So a polygon is composed of one or more triangles which all lie in the same plane. For instance, a square polygon which is made up of two triangular faces. Procedural. This is an algorithm which generates data within the 3D graphic application. For example, procedural 3D textures are patterns which do not require mapping coordinates. And procedural animation generates motion and may not involve keyframes at all. And procedural modeling employs the simple rules to generate complex structures such as plans. For example, in Maya's paint effect, this is a superb example of tool for procedural modeling and animation. Then progressive scan, video display mode, which draws each scan line. Right? A video display mode which draws each scan line, row means row of pixels, sequentially and does not use alternating fields. Radiosity. Radiosity, this is the rendering which accurately simulates the propagation of light energy throughout an environment. Radiosity works by calculating the effects of light bouncing off the objects to illuminate other objects. Means if these are various objects, light goes here, then goes reflected and coming down, refracting. All these things are considered. So in a global illumination algorithm, meaning its account for the ways in which light is transferred among surfaces of the scene. In raster images, this is a 2D image which is composed of a series of horizontal scan lines arranged in vertical rows. So digital raster images comprise of grid matrix of pixels which I just mentioned. So all bitmap images are raster based. And converting this conversion of a vector based image to a pixel based image, this is called a rasterization. The ray tracing. This is a type of global illumination rendering algorithm that excels at reflection and refraction. Ray tracing, global illumination that excels reflection and refraction. So ray tracing realistically depicts scenes by calculating the rays of light entering the virtual camera lens So it works by drawing a ray from each pixels of the rendered image backwards into this scene until it intersects with the surface. So if the surface is reflective or refractive, additional rays are generated, bouncing off the surface until they intersect with the other surface and possibly generating the additional rays. So this method is also used to generate ray trace shadows. So if a secondary ray bouncing off a surface has a clear line of sight to a light in the scene, then that light contributes to the color of the surface and the point of intersection. Then reflection map, a simpler method of rendering reflective surface than the computationally expensive ray tracing technique. Right? Rather than using ray tracing technique, this is a simple method of rendering reflective surfaces. An image is mapped onto a reflective surface. As the object moves, the reflection map maintains its orientation to the world coordinate system, giving the illusion of a scene reflected in the object. Refraction, this is a very common physical phenomena, a bending of light rays passing from one medium to another, and it depends on the refractive indexes. This can be simulating using refractive mapping, similar to refraction mapping, or through ray tracing. Then rendering. So in computer graphics, the process of producing this 2D image from a 3D scene is termed as rendering. 2D from 3D. So this during rendering, a computer draws a 3D object to the screen and to a file, usually a bitmap. So real-time rendering occurs when viewing objects in interactive viewports on games or simulations. So no real-time production rendering draws much higher quality image at the expense of speed. So production render may take anywhere from a few seconds per frame to an indefinite period of time, sometimes hours or even days for a single frame. Then comes rigging. The process of setting up interactive controls for 3D characters or complex mechanisms. Rigging is a technical process. It's sometimes called a character setup. So the process of setting up a powerful interactive controls for these 3D characters. A good character rig map makes it easy for an animator to focus on creative expression like acting. Script in computer graphics, a script is a program that is interpreted and run by the host application. For instance, Maya uses a scripting language called Mel and Python, while 3ds Max use MaxScript. So scripting takes the tedium out of computer graphics by automating the tasks, and it can also add functionality to the host application, which is similar to a plugin. And scripts are human readable and are not pre-compiled to binary code like most computer programs. And this shading algorithm, this is a high-level rendering algorithm to represent how a surface responds to the light. It's a shading algorithm. So a piece of computer code that is part of a material definition, for example, a blend shading algorithm, which generically describes how highlights appears on the surfaces. With smoothing, a rendering algorithm to give the illusion of smoothness on the polygon mesh surfaces. So without smoothing, all polygonal objects would have a faceted appearance actually. So this is also known as edge smoothing or face smoothing. Smoothing can be accomplished through the rotation of vertex normals. The specular, color of the highlight on a shiny object. Color of specular highlight is often determined by the color of the light, then by the object's color. And then we have the spline in computer graphics. A spline is a line whose curvature is determined by it's only a line, but its curvature is determined by these control vertices. So originally a thin wood or a metal strip is used for this construction. The subdivision surface algorithm that adds density to polygon meshes. Subdivision surface. So it can be used as a modeling tool or invoked during rendering. So low density mesh objects are smoothed through tessellation and smoothing of angles among adjacent surfaces. In Supersampling, an anti-aliasing algorithm that internally renders at high resolution and averages pixel value for a lower resolution. And this significantly reduces aliasing on some textures at the expense of longer render times. This is also known as oversampling. The surface of revolution. A modeling technique, this is used to create rotationally symmetrical 3D objects, that is by revolving a spline around an axis, commonly employed to create objects such as bottles and lathed furniture pieces. Tessellation, a division of a surface into smaller polygons, yielding a higher level of detail. This is tessellation. In texture map, a bitmap or a procedural map to vary some property using diffuse color across the surface. So the term texture map in this strictest sense means the diffuse color map. You transform, a mathematical reassignment of points to a new location. This is transform. So it's the abbreviated form of transformation. The three transforms are rotation, scaling, and position, that is translation. These transforms control the location and orientation of objects in this 3D space. Then vector, or computer-graphics, a vector is a curve or a line in a 2D or 3D space in this computer graphics. So in mathematics, a vector is a straight line with a length and a rotation, and a vector will be defined by any 2 points in a space. It is commonly defined by a single point, an angle, and a distance. And for this 3D, you require 2 angles. For example, in Maya, MEL scripting language, vector refers to the group of 3 numbers such as x, y, and z positions of a vector. In vector graphics, methods of calculating or displaying data based on the lines and curves rather than pixels and voxels. 3D models, 2D illustration paths, and digital typefaces are all examples of vector graphics. And 3D models are constructed in vector space and usually projected onto pixel space for display. Vertex, this is a plural of vertices, a fancy word for a point. Points are merely markers in space. They have no dimension whatsoever, no length, no area, no volume. Vertices serves many functions in 3D graphics, right from defining the contours of objects to anchoring parts of a hierarchy together. So vertex normal, line joining or pointing out from each vertex of a surface, important for lighting and edge smoothing. So the orientation of vertex normals determines how much light the surrounding surface can receive. Vertex generally have several normals, one for each face shared by the vertex. So if all all normals on a vertex are aligned, the renderer draws gradients across the connected edges. So if normals on a vertex are pointing in different directions, the renderer does not smooth the edges, resulting in faceted appearance. Coming to voxel, this is volume element which is compared to pixel. Voxel is a cubic section of a volume. This is used for calculating certain volumetric effects such as fluid dynamics. And Z-buffer, an automatic method for managing depth information in a 3D scene. It optimizes rendering by selecting which surface to render and in what order. And the Z-buffer ensures that these hidden surfaces are not rendered, saving the time. Z-buffer or depth buffer information can be stored within certain bitmap files such as .rla and EXR. The Z channel records the distance of each pixel to the camera. This information is useful in compositing. A simulated lens effect such as distance blur from depth of field can be added and adjusted after the 3D images have been rendered. So this was all about our 3D graphics terminology. Thank you so much. Take care.